Okay, 4.2, we're looking at some probability rules of compound events. So first off, we have independent events. Two events are independent if the occurrence or non-occurrence of one event does not change the probability that the other event will occur. For example, if you flip a quarter and flip a dime, it's not going to matter what you get on one. It will not affect what you get on the other. So I could get a heads on one, a tails on the other, and it's not going to affect me getting one of the other on the other coin. Dependent events, two events are dependent if the occurrence or non-occurrence of one event does change the probability that the other event will occur. So for example, if you draw two marbles from a bag without replacing them, drawing the first one means you're going to have one less for the total. So your probabilities change because you took one out and didn't replace it. Now we've got multiplication rules. We go through these. If you know that two groups are independent, you're just going to multiply their two probabilities. If you don't know the two groups are independent, we have to multiply still, but this time we're going to be using the conditional probability also. So when you see that P of B bar A or P of A bar B, that means if you look here, we have the probability of A given B occurs first. So if it goes A bar B, that means we want to find the probability that A happens, but first B has to happen. That occurs when we have two events that are dependent because one is going to affect the other. So we first have to find the probability that the first one happens, and then we have to change the probability then for the second one. So for example 4, it says, suppose you are going to throw two fair dice. What's the probability of getting a 5 on each die? Now, if you roll a die, it does not affect the outcome for the other die. They're going to be two separate events. So that means they're independent. So we're going to have a 1 in 6 chance of getting a 5 because on a die, it goes 1, 2, 3, 4, 5, 6. So I have 6 options. Now, on my other die, I also have a 1 in 6 chance. So when I multiply those two together, I get 1 out of 36. So I don't have to change anything with my fractions because I have two independent events. I want you to try number 4 here. So pause it and look through number 4. Okay, you should have an answer for A and B here. Now, first off, we're looking at lifespans of Andrew and Ellen. Now, these are two different people. The lifespan of one is not going to affect the lifespan of the other. So these are going to be independent events. Now, if they want you to find the probability that Andrew is alive in 10 years and Ellen is alive in 10 years, we're just going to multiply the two probabilities together. And means multiply. Whenever you see the word and, you're going to multiply your two values together. So we have a 0.72 times 0.92. So that gives me a probability of a 0.66. Now remember, your final probability can never be bigger than 1. So when you multiply these and you happen to get an answer that's maybe a 1 point something, something went wrong. Probabilities will never be over 1. Again, when you see the word and's going to tell you to multiply. Now if I look at example 5, we have a collection of 6 balls. They're identical except in color. 3 green, 2 blue, 1 red. They want the probability of drawing 2 green if the first ball is not replaced. So you have to think of what this means. If I'm drawing a green first, there are 3 greens out of, the total always goes on the bottom, 6 of those balls. So 3 out of 6. Now if you took a green out, we don't have 3 greens anymore. We have 2 greens instead. So it's going to be 2, and we don't have 6 anymore either because you removed 1 from it. So instead of 6, it's going to be 5. So you're going to multiply those two together, And when we do that, we're going to get a 6 out of 30 or a 1 out of 5. So very similar if you go to number 5 here. So I'm going to have you pause again, try number 5 on your own, and then come back with me. Okay, so you should have some answers here for A and B. Here we're looking at testing digital cameras, and we have 100 of them. And it says we're going to check the first one and then not replace it, check another one. We want to find the probability that both cameras are defective if it contains 10 defective cameras. Well, since we're removing a camera and not replacing it, that has to be dependent. So the probability of the first camera is defective. There are 10 out of 100 because there are 100 in the group. Now, if you've taken out a defective camera, we don't have 10 anymore, we have 9. We also don't have 100 total, we have 99 total. So we're going to multiply those together, and we've got 1 out of 110 for our final answer. Again, we're looking at ands here. Whenever you have ands, that means we're going to multiply. Or if it says something, then something, again, we're going to multiply. Whenever you have the thens or the ands, you're multiplying your two groups together. Now, addition. If and is multiply, or is going to be at. So, or occurs when either something happens in Group A, Group B, or together in A and B. So if you look here at our picture, we have A is pink, B is blue, and their overlap there is going to be like purple leaf color there. Now, if you're looking at A or B and you have an overlap like that, you're counting some numbers twice because those numbers are both included in the B group and the overlap group. So because we have overlap to it, we have to get rid of anything they have in common. So with the ors, you have to pay attention to see if there are any numbers in both groups. Because if they're in both groups, we're going to subtract those numbers out. Okay, so for example 6, we have to figure out if it is an and or an or. So for A, I have satisfying the humanities requirement by taking a course in the history of Japan or by taking a course in classical literature. Since we're looking at or, it's an or. For B, buying new cars and aligning the tires, that would be and. For C, getting an A not only in psychology but also in biology. So you're saying an A in psych and bio. Then it says having at least one of these pets, cat, dog, bird, rabbit. So you're saying cat or dog or bird or rabbit. So for example 7, we've got to think what they're asking us here. We've got 31 students. We've got freshmen through seniors, and we have the males and females shown. For A, it says, suppose we select one student at random from the class. Find the probability that the student is either a freshman or a sophomore. So we have to know what the total number of freshmen are and the total number of sophomores. So we would have 15 total freshmen, and we have 8 total sophomores. So when we want to find one group or the other, we add together. There are 15 out of 31 freshmen, and there are 8 out of 31 sophomores. Now, as we go through this, we've got to think, can you be both a freshman and a sophomore at the same time? No, you can't. It's 2 separate classes. So I don't have to worry about getting rid of any numbers because they can't be both at once. So all I have to do is add the 2 together. Now for part B, we have what is the probability that the student is either a male or a sophomore? Well, we know there are 8 total sophomores, but now we have to add up the total number of males. So if I add up my male row, that's going to be 14 there. So now we've got to think. There are 14 out of 31 males. There are 8 out of 31 sophomores. But you have males that are also sophomores. So that means you're including those 5 males twice. So you're looking at them as both males and sophomores. So really, in my group here, we're saying there are 10 males in that group. We don't want 10, we only want the 5. So we have to get rid of any numbers that overlap in both groups. Now you're not subtracting 10, you're subtracting 5. Because we want to get rid of one of those 2 sets of 5 because 5 is included in the 14 males and that 5 is included in the 8 sophomores. So we want to subtract 5 out of 31. When I subtract those 2 then, we should have 17 out of 31. Now going through this, I kind of introduced mutually exclusive. So 2 events are mutually exclusive if they cannot occur together. For example, freshmen and sophomores were mutually exclusive. However, sophomore and male was not mutually exclusive. So if you look at our 2 formulas here, if 2 things have no things in common, we just add them together. But if they have something in common, so like sophomores and males had something in common, you have to subtract the number they have in common. So we had to subtract that 5 that they had in common.